Hello everyone, welcome to my YouTube channel. And currently we are doing the top interview 150 question. And today we are going to do our next question, which is going to our sixth question. But from this video, we have tried a new approach, and we are going to explain you the algorithms from the notes created by me. I will also going to share these notes in the description below, so do check it out. Now, so the question for today, which we are going to do is rotated array. So here the question, it states that given an integer array nums, rotate the array to the right by k steps where k is non-negative. So we are given an integer array nums, which is here you can see an example 1, 2, 3, 4, 5, 6, 7. What we have to do, we have to shift it in the right side in k steps, which is here 3. So you can see an explanation that what we have to do, we have to shift it to the right side. So to understand this, you can assume that this nums integer array is just linked from first position to right position. So from starting and the ending, it is connected. So in the first step, when we rotate by first step, what happens is that the last element in the nums array, which is here 7, goes to the first position, and all the elements present before it just shifts to the right. So this is happening in each step. So the last element is going to the first position, and all other are going to shift to the right index. So to implement this question, we have to check out or understand some approaches which I have mentioned in my notes. So let's go there and understand the all the approaches which we can apply. Okay, so here I have also included the link in the heading of the rotated array. So you can directly go to the link and solve the question. Now, here is I have included a note to understand a very important concept which is important for every approach, is that we have to take k modulo n in every step. This will provide us with the exact number of times we have to rotate our integer array, because if the size of the integer array is 7 and we are getting our k is greater than 7, so if we rotate our integer array 7 times, it will regenerate the same initial array, so it doesn't make any impact on our solution. So we have to find out the k value which is going to impact our solution. So the k mod n is going to give this value which we want for our all the process to execute. So here, if we take 10 mod 7, what we get? We get 3. So now let's see the first approach, which is brute force approach. So what we are taking, we have our k mod n, which is giving us our the exact number of times we have to rotate our array. So in this, we have to follow the same steps k times. So the steps are very similar to what we have just understand in previous example. So what we have to do, we have to store the last element in a temporary variable, and we have to just shift all the elements starting from first position to second last position to the right. And after that, we will just insert the temporary variable to the first position. So our first rotation gets completed. Similarly, we will do our second rotation and our third rotation. So in three rotations, because we have k equals to 3, we get our final rotated array. So this is the brute force approach which we can apply. So here the time complexity is going to be k into n, big O of k into n, because we are going to shift the n number of elements to the right. So that's why we have big O of n, and we have to do it k times. So our big time complexity becomes k into n. In here we have used just simple integer to store the last elements. So our space complexity is going to be big of 1. Now let's move to our second method, which is using extra space. So in this method, we are going to use extra space, which is a vector array, or you can use list in the different ways. So here we are going to use an extra space, which is equivalent to a vector in our condition, and we are going to just copy the output to that vector which we have created. And after that, what we do, we will change our nums integer array equals to our auxiliary array. So here you can see what we are going to do in this approach is that we are going to put this last three elements, which is equals to k, to the first position in our auxiliary array, and the first left elements to the last position, and after that we will copy this to our nums. So this will gives us our output. Now let's code it and understand how we are going to do it. So first we are going to take a vector, let's take it v, and now we have to take, let's take n equal to nums dot size. Okay, so one point which you have remembered, that we have to do k is equal to k mod l. Okay, now we are going to run a for loop. So first we have decided to start for the last. So how we are going to get there? We are going to take int I equals to l minus k. Now let's see here. So here L is equal to 7 and K is equal to 3. So our L minus K is going to 4. So it is going to point at this position, which is in 5 pin here. But we have index starting from 0. So it's came at this position. So we are starting from this position. So we are taking the last K elements. Okay. So it is ensuring that we are going to take last K elements. So from this, I less than L, I plus plus. So what I have to do, we have to insert v dot spec nums I. Okay. Now similarly, we are going to run again for loop for the left ones. And in here, what have to start, we have to start from first position, which is 0 index, and we have to move till L minus K. I plus plus. So notice here we have start from L minus K, and in here we are stopping just below L minus K because we are taking I less than L minus K. So we have just stop at this position. Okay. Now so I will left end. Now we have to again do v dot pushback nums I. So it is final. Our auxiliary vector is already filled with the valid input. Now we have to just copy to the nums. So again run a for loop and I equals to 0, I less than L, and I plus plus. And what we have to do, we have to do nums I equals to vi. So this is the final, and it should give our result. Let's try to run this code. Okay, so it accepted. Now let's try to submit to ensure that all test cases pass successfully. Okay, so it is successful. Now, okay, so in here we have done the coding part. Now the time complexity is going to be big O f n, because we are using the for loop 3 times. So each time it is n. So it is big O of n, and the space complexity is big O n because we are using a space of a vector of size n. So now let's move on to our next method, which is using reversal technique. So this is the most optimal or easy technique which you whatever you can say. So in here, what we are going to do, we are going to reverse the set of the elements, and by reversing them, we are going to find our final output. So you can just see the steps which it has going to we are going to follow. So first, we are going to do entire. We are going to reverse the entire array. Then again, we are going to reverse the first k mod n elements, and last we are going to reverse the remaining elements. So this is the algorithm. In the first step we are going to reverse whole entire array. Now next time we are going to reverse the first k mod n. So these are the three elements which is k mod n, we are going to reverse them, and in last we are going to reverse these elements. So this will give out the our final output. So it is based on our capability to see the question. Now the time complexity is going to be big O of n, and the space complexity is going to be 1, because we are using reversing. So it is time complexity of n, and a space complexity we are do not using any extra space. So it is the most optimal approach. Now let's code it and understand how it is going to work. So let reset. So this I'm going to use a different approach to make you understand better. So here what we do, we will first take int l equals to nums dot size, and again k equals to k mod l. So this is the simple first step which we have to do in every question. Now what we have to do, we have to reverse. So we have to reverse. So first reverse, so in algorithm you can do any steps, it doesn't matter what you're going to do. So you can do it in two ways. First you swap, reverse the whole array, then swap the first k and l minus k elements, and then the remaining one. But the second approach you can also follow is that first swap these elements, then swap these elements, and last swap all the elements. So whichever which you like, you can do that. So I am going to use this approach where we are going to swap first these last three elements, then we swap the remaining elements, and at last we swap the whole array. Okay, so first swap these. So we are going to start with nums dot begin. Let's take it from end, nums dot end minus k to nums dot end. So it is going to the swap the last these elements. Now let's again, we can just copy paste this. So in the second we have to swap the first, so we have to begin, and at last we are going to use end minus k. In here we are going to use begin. Now let's try to run this code. Okay, so we have left semicolon. Okay, so the code is already, test cases is passed. Now let's try to submit and find out. Okay, so it is successfully submitted. So these are the three algorithms which we can use to solve this question: the brute force, the normal one, and the most optimal one. So you can use these approaches in interview. Now, this is the all for this video, and I will going to share this algorithm sheet with you in the description. So do check it out. Thank you, everyone.